Thank you, Dr. Jill Bush, for your kind introduction. I want to thank the NSCA and the Research Committee and Consortium for their kind honor and invitation to give this year's Dr. Gary A. Dudley Lecture. It's truly an honor. If you go back and you look at Dr. Dudley's career, both from the NSCA and also with regard to scientific work in general, he was one of really the most creative thinkers that I've been around and was fortunate to call friend. I really think that this lecture, in part, is going to hopefully each year represent his memory, and hopefully we can do it justice each year as he would have wanted. I think the key thing that we see here is also the fact that he used a lot of technology long before anybody else really understood how to use it. One of the big insights he had was the use of MRI to look at muscle activation. And in fact, if you look at the phenomenon, he was the first to use weighted T2 imaging to actually look at activation in muscle. And if you look at the phenomenon from the control to the post-exercise, you can see you can dictate exactly what the patterns are here in the squat. That was basically, you can see from the left to the right thigh. And you can also see that basically technique is important because you can see differential activation. So I think he came up with many different types of ideas and concepts that at the time were well ahead of their time, and from that standpoint. Now his interest was in training. I think up until the last weeks that he was on this planet with us, he was still talking about training and still trying to understand what goes on with regard to the muscle and its phenomenon related to that. I just wanted to point out that he was also an avid actual NSCA member and really helped us push the NSCA in its early history toward where we are today. This is the item writing committee in 1985, and here's Dr. Dudley in all his former basketball height glory. You might notice some of the other people here. We've actually aged a little bit. This is myself. This is Dan Wathen, who's in the audience, Dr. Beckley, Dr. Garhammer, and your current president, Dr. Fleck, when he had a much more voluptuous type of hairdo. So the bottom line is, Gary was really very important in the area of NSCA, helping launch the research aspect, brought people in, and really contributed a lot. So it was in 2007, after his passing in 2006, he did receive the NSCA's Lifetime Achievement Award, and really goes down as one of the real pioneers in research and resistance training. So my topic today was an area that Gary also had interest in, is really looking at the phenomenon of compatibility of two exercise modalities. And I know there are a number of great reviews that are out there right now. One will be coming out in the Journal of Strength Conditioning Research relative to a meta-analysis by Dr. Jacob Wilson's group. One of my former postdoc, Michaela Squerto, has one out in 2011, and also Per Aagaard from Southern Denmark wrote another one in 2010. So there are a lot of different reviews. I'm going to touch on some of the key issues today, and not necessarily everything, but I think we're going to get a bit of a look at it. Well, let's look at it from a historical perspective here. If you look at historically in the 1970s, and this really stimulated my interest too. I was wondering why, as a football player, a coach had us go out and run 5-mile runs. But it was part of the genre. If you think of it, and this is the classic picture of Rocky Balboa, is that the concept out of boxing came into the concept of road work. And I think it still is a concept that we go out and do road work and we get in shape. And typically this is what spurred some of the ideas relative to this. But coaches and athletes were concerned a lot of times by adding a strength power training program, especially to endurance athletes, that in some way you were going to harm their aerobic capacity or their aerobic power development. So if you look at that concept, it was actually fears from the initial findings in the late 70s that shows, just from a dramatic area, if you strength train and you get bigger muscle fibers, basically it pushes out the mitochondrial density, and it was really just a scaling measure. So this concern, though, reverberated, especially through the endurance community, that we don't lift weights because it's going to decrease our fundamental organelles of mitochondria, and we're going to reduce our density. But they didn't realize this was really a measurement phenomenon. If you look at compatibility and simultaneous training, this really is about the construct of using two modes of exercise simultaneously and recruiting those motor units to do both forms of the exercise that we'll talk about more later in the discussion that we have. And basically, what we're dealing with is an oxidative stress and a high anabolic stress for size, and one that basically you'll see later is not necessarily promoting the size production. If you look a little bit further, we have a challenge training athletes. Now, many athletes we see are not necessarily at the extremes. Now, definitely extreme marathon runners and ultra distance runners still are faced with the challenge of really putting in enough anaerobic or strength training type of exercises to help prevent injury. Even today, looking at training logs of some of the elite ultra endurance runners, they do not spend enough time in the weight room. And you can see this across the board. And even if you go way over to the far right for Olympic weightlifters, shot putters, powerlifters, the concern that they're going to go out and run 5 miles a day maybe isn't that much of a concern. I think we're where we are now, nobody's going to prescribe that. But for the majority of athletes, what we're faced with is the cardiovascular system being trained and also the power output and power being trained. So there's a conflict, there's a strategy of two opposing forces trying to both get training time. And there's a lot been written on this as well. So initial studies, let's go back historically. Initial studies didn't really look at this until about the 1980s. And we were really seeing some of the first things. Well, what stimulated the first interest came out of the University of Chicago at Illinois, and basically by our late friend, Dr. Robert Hickson. And I know that his work early on with untrained subjects actually focused on the construct that if we're going to train 3 days a week aerobically, as you'll see, 3 days a week with strength training, and we do it together for 6 days a week, alternate workouts, that in untrained athletes, what they ended up seeing here, as you'll see a little bit more later, is by the 7th week, you started plateauing, and then you saw a decline in strength and force and one-arm strength going down here. So this was one of the first concerns that really brought the concept of compatibility to the forefront. So it was this construct here in these untrained individuals that really pushed everything forward relative to, hey, there may be a problem when you do two things together. So if you look here, they had a strength group, they had an endurance group, they trained the strength and endurance group, just combine these two. So every day they were training in 6 days a week with only 1 day a week rest. You also see that they had increases in the combined group of both of the VO2 max, no problem. And this is something you'll see in all the studies. Maximal oxygen consumption, for the most part, unless you're dealing with more elite athletes, has not been a problem when you combine any strength program with it. And what you'll see over here is that the strength group, you found no increases in VO2 max. So for those people that think you can increase it with weight training alone, and I'm talking about strength training of heavy loading, not the light circuit program, very little changes occur in the oxygen consumption capacity for obvious reasons. But you see that in strength, what in his study, as I said, by 7th week, it declined. You started to see a decline over the last 10 weeks in these untrained individuals. Well, you can see here again that this is the concern that basically brought the whole thing to the front. Now, Dr. Dudley had an interest in this too, and he saw this information, and by 1985, in his group at Ohio University, they started looking at this in a very unique way as well. And incessantly, what you got to realize about Dr. Dudley's initial studies on this is they did a very intense program with 3 days a week consisting of interval cycling at 5 times 5-minute intervals. And what happens is during this 5-minute interval, they went to peak VO2. Now, any of you have been on a cycle to get the peak VO2 each time, that's a lot of hard work. You don't just ride along, like you're out for a drive. This is hard work. And Dr. Dudley was famous for really knowing how, was his soreness studies or this study, he knew how to really pound you. And I'm not kidding you, he did. And what happened in his strength training group was an isokinetic group because, again, he used that as a measurable phenomenon, but he got people working 2 sets of 30 at fast speed, and he really worked them very hard. So you're really doing maximal challenges to the neuromuscular system. And what he really found in this study of only a short period of time in relatively untrained people again, was that if you look at the torque versus velocity, you made changes down here at the slow velocities, but high velocity power, where you needed to really pound you really get at the torque production on the isokinetic testing, it was really no difference. It didn't separate. But if you look at his program, you can see why that might be the case. So in reality, what happens is that we started to think, well, maybe it affects power. Maybe the neuromuscular recruitment patterns affect the power phenomenon more than actually just pure force production. So some things are affected, other things aren't affected. You always got to go back to the program design, and that's key in all this type of thing as well. So by the mid-1980s, we knew in general from a few studies that were out there that high velocity torque production was being affected. You knew, in fact, that there was strength development could be compromised over a long training period when it was potentially done with a high number of days per week. And endurance capabilities, we didn't have a problem with. VO2 max, et cetera, was not happened, and I was trying to figure out, well, why does this occur? So the concept then was overtraining. We're much more sophisticated now as we look at the construct of overreaching, from functional overreaching, where you know what you're doing, non-functional overreaching, where in fact you don't know what you're doing and something's going on and a performance decrease occurs. And then now, as most people will look, overtraining is a serious problem which really decreases performance for months or a year. I mean, it's really serious and maybe not very frequent. But in those days, they said, well, maybe these untrained individuals just couldn't tolerate the total amount of work. So it was just too much. So the solution eventually was the fact we need better sequencing and more rest. And I'm struck today by the fact that history that we don't remember, we have a tendency to have to relive. And if you look at a lot of commercial programs out today, pound, 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 rest, pound, 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 and you get this type of phenomenon where the toleration of work at very high metabolic intensity with the heart rate is very demanding from an oxidative stress standpoint. So you can keep that in mind relative to periodization and basically sequencing. So when you're starting from the untrained state, too much, too quick, too fast, the toleration of the adaptive mechanisms to actually mediate what you're trying to accomplish with the muscle fiber and with the neuromuscular system in general and all the support systems is just too much. If you look at really another study was adding strength training to highly trained endurance runners, by the late 80s, this was a concern that Dr. Hickson had for elite endurance runners, 5K, 10K runners. So what he did in these studies is he tried to wreck their 10K time, wreck their 5K time. So he put them on heavy 5RM, heavy loaded 5RM, heavy squat training. We're going to wreck these guys' training, show that it's a problem. And what serendipitously happened is that even here, if you look at what's going on, adding this strength training, this very heavy squat training and strength training in these endurance athletes did not really affect any endurance capacities. So in fact, what Bob Hickson told me back at a conference when he first presented this, it actually improved their hill running capability. So we found that it was difficult to wreck endurance capacities by just doing heavy strength training with some reason, not ridiculous programs, but common sense programs. So by adding this phenomenon, the interesting finding was that it was first overlooked, is that when you look at strength training addition, it resulted in no changes in the aerobic capacity measures of metabolism. But one thing that was missed is the fact that there was no changes in the girth or muscle size. And this is something you'll see coming through again, that it was difficult to gain size or girth of your muscle. Even though you're strength training and a group that does that alone sees it, you don't see it in these endurance athletes. And maybe we can look at that and think about this maybe came out back then. So you can see short-term endurance, as I mentioned, improved. They got better with short-term endurance for probably a lot of reasons. They basically saw a phenomenon where this was important for endurance athletes. So your ability to kick, your ability to do things in a dramatic manner of a short-term nature were improved when you added this type of strength training to your program, which included heavy 5RM type squats and other exercises. They also saw increases in all the specific muscle groups, which you might not be surprised at. Remember, strength is going up, but girth and size is not. So you can see here, parallel squats went up. You know, you got knee extensors and flexors, everything went up. But again, keep in mind, something that wasn't appreciated in '88, the size and girth wasn't going up at all. Thus, the endurance runners by the late 80s should have been pretty comfortable that this is not going to affect your particular phenomenon of what you're trying to accomplish with regard to your endurance performance. And he showed in an abstract that he published and presented but passed away before he could publish it, 5 and 10K times were actually improved. So this is really interesting with regard to aerobic function and adding strength training on top of it. So entering the 1990s, we got into simultaneous training may inhibit normal adaptation. And again, this conflict between the anaerobic stimulus versus the oxidative stimulus to make sure that you're trying to change, I should say, oxidative stimulus. Anytime you recruit fibers, by the way, it's an oxidative phenomenon. So that's one thing you got to realize right up front. But it's the extent of that recruitment that we're talking about. So what we see here is Nelson and the group here did a small study, and they were one of the first studies to look at this again at the fiber level in the early 1990s to try to see what was going on, and they look at the characteristics. So if you look at this, the combination of both intensity aerobic training, and again, they use maximal isokinetic strength training. Why did so many people, including Dr. Dudley, use isokinetic training? Because people in the scientific communities accepted it as a measurement tool. Third-party billing occurred. People accepted that as a measurement tool, even when it was done incorrectly. You'll notice that what Dr. Dudley did, he tested and trained with the same modality. We had studies that train dynamically but test isokinetically, and there's a mismatch of the training phenomenon. So just to keep that in mind. But again, they could show that there was a potential decrease in the magnitude of change in the oxygen consumption. And this was in athletes that were looking at quite endurance cycling, which you saw this improvement. So they saw 11 and 25% gains in type 1 and type 2A muscle fibers, yet their isokinetic group here only saw it in type 2A. Again, the speed of which you were training at and the recruitment pattern that was occurring. So if you look at the whole phenomenon, there's a concept that came out of this time that cycling may be less disruptive to fiber changes than running. And you'll see later this maybe was proven by some other studies that have been just starting to eke out this phenomenon. And if you think about it, the mechanics of cycling, no eccentric loading, no pounding, no impact, and you can see that that might have some relevance to what's going on with regard to the muscle adaptations. So the question came up then about same or alternate day. And one of the first groups to look at that was out of sales group at the time in McDougal up in McMaster, looking at, again, you got to look back to the program that you're looking at. You got 15 to 20 reps, and you got 8 sets of high volume. So this is lightweight. Recruiting, as you'll see, lower threshold motor units for the most part. You're going 3 times a week for 22 weeks with a break in the middle. And basically what they concluded was that when they went on the 2-day a week, they found a 26% increase in hypertrophy to 4-day a week, only 6-day a week. So when they went on the same day, they were actually getting some better effects than if they went on a 2-day. But again, you got to look at the program that's being utilized in this particular study. So I think this is really one of the things that is really interesting relative to compatibility studies, or what are you putting together? What are you putting together in program design, and how does it relate to motor unit recruitment? And how does it relate to damage effects and things like this that occur, as well as the type of things that are stimulating growth and repair? So conventional resistance training, this is a classic study by John McCarthy when he was at Wisconsin. Basically what he did is he was the first one in the mid-90s to take a conventional approach. And when he trained people with really a solid strength training program here, looking at 70% of the heart rate reserve, looking at a program of aerobics that basically was stressful, but it wasn't over the top, as you see many people are today, and looking at barbell squats and benches and all these and free weights, looking at a program of 6 rep sets and this type of thing, putting it together on the same day, working it out over this period of time. He didn't see any incompatibility. And this really set the stage for the fact that if you program it right, are you necessarily going to see an incompatibility? Now, nutrition is going to play a big role in this as well, and there are other external factors that deal with this as well that we can see. So from this, again, more realistic programs with proper progression, proper starting points, put together in a fashion that's realistic, especially when you start with untrained individuals again, you basically can manage it more effectively. And that was really the first study to try to bring reason to the whole phenomenon. If you look at heavy versus light on the same day, one of the things that you see again with the comparison of things is how you put repetitions together. Training with an intense cycle loading, it can decrease force due to the oxidative stress. Compared to a conventional same time of day program with lower intensity, you're going to get a better aspect. So there's this challenge again for those motor units faced with high oxidative demands that basically are challenged by the anaerobic aspect, which is really force production that we talk about. If you look at rest and recovery, I think from the work that we've done in the past, that Dr. Fry did from his work many years ago on overtraining, as we called it, you need rest, and day rest can help a lot, but rest amount is dependent upon what you're trying to recover from. So many people are accumulating stress today in different programs, from commercial programs to Ironman training to a host of different things, because their body is not allowed the time to basically recover and recharge from a repair remodeling standpoint and basically be able to come back and exercise again successfully. So we get into a chronic breakdown mode in many ways. And in young individuals, especially athletes, they can go through a lot, they can absorb a lot, whether it be from the military or athletes or highly motivated people in some programs. They think they're okay, but in reality, underneath it, they're a ticking time bomb. And that's part of the things that we're seeing now, and a lot of things that ultimately relate to injuries because break points are being removed, they're moving down. So there's lots of different difficulties when you look at that. Well, I was interested in the question early on, and it took me a while to get it published, but when I was in the military, we did a study I think has been really one of my classic studies I'm very proud of. We took really highly fit subjects that were not necessarily highly weight trained from the 101st and the 82nd Airborne, and we basically were going to put them, this was the most ideal study I've ever done, because all these guys did were come and eat, train, and test. Very unusual, so maybe you got to put it in context. Eat, train, and test. So this is the chance. We even had our one group that was combining just doing strength training alone, where we did a 2-day metabolic training protocol, said here's your chance to show the VO2 max improvements. So what we did was, if you look at it, this is where some of the commercial programs took some ideas that only they went overboard. On 2 days a week, we did really supersets and short rest protocols right down the line, almost like a bodybuilding program. On the other 2 days a week, we did our heavy loading type of exercises at the 5RM level. And then on workouts here, we did high percentage VO2 max 40-minute runs that was matched up. Again, these were done in the morning, these were done in the afternoon. And then the interval workouts done in the morning, and other ones separated by 6 hours in food. So the other thing that hasn't really been looked at enough, I think, is how nutrition plays a big role, because a lot of them are jammed right together. So we were probably the first to look at metabolic training in a way that with 2 days a week. But remember, we rested on Wednesday, Saturday, and Sunday. So that's another element of context. If you look at the phenomenon, again, strength training did not appear to really have a problem with the VO2 max. The combined group improved over 3 months. The endurance group improved over, and we had an upper body only. For that reason, a lot of guys like to just lift on the upper body and do nothing on their legs. I don't think we see a lot of people doing that anymore, maybe. But we found that if you trained with the trained running, you got better with running. If you didn't, no matter if you did circuits, and these were double max tests to verify it, you can see 53.47 to 53.02. These are some of the tightest ICCRs I think we've ever had in my life. So reality is, even with metabolic training, if you're relatively fit, you're not going to get an oxidative stimulus that's enough to change your maximum oxygen consumption. Strength training did as you would expect in the leg press and the bench press. Technique is kind of limited. We do more squat stuff now, but back then you get better. And even the upper body for the bench press, you get better if you trained it. So if you trained it, specificity holds true and you get better. If you look at the phenomenon of power though, here's where it got interesting. In fact, what we found out was the fact that only the strength training group, because remember upper and lower body, saw improvements in power in all the different upper power, legs, power, mean power, peak power with the classic Wingate testing. If you look up here, we didn't see anything in the legs going on, and the only thing was the mean power in the arms for the combined group. But again, there was no oxidative stress directly on these motor units of the arms in the cranking test. So again, this is where we saw there was a little bit of incompatibility for the power activity that you're looking at, and it's something to be considered. If we look at fiber typing, this became a replication of some of the things other people have done now recently, but what you're gonna see with skeletal muscle, here's the 4-6 stain from our old laboratory. If you look, you can see the 2X, the 2A, and the 2XA. Well, one of the things that even happens with runners training with weights, and Per Ergaard showed this recently as well, is that you're always gonna get the transition to go from the 2X to the hybrid fibers to the 2A fibers. So that transition occurs, and that's maybe a positive adaptation that helps some of the running economy and helps some of the capabilities that we see in the aerobic maintenance of function. So from that standpoint, we learned a little bit about this. Now, if you look at the fiber changes, what we find, I'll show you in another figure here soon, is that realistically, you saw transitions occurring. So you're getting the shift over from X to A. In those days, it was B to A. But now we know it's the X fiber. But really what happens, you can see here, is the transition occurs in all the groups that are using the strength training. But here's what happens to the groups. It's really a very straightforward phenomenon with cross-sectional muscle size, muscle fiber size. Remember I said early on, Hickson found that there's no girth increase in these guys who actually run. Now, we've shown it, and other people have shown it, depending upon when you use cycle exercise, it's not as evident as when you're using running. These guys were doing running. So the endurance group actually saw sport-induced or training-induced atrophy. Fiber size of the type 1 fibers decreased in size. Now, again, you don't see that when you're cycling. These guys were pounding. And basically, they're only doing running. And this is some of the phenomenon that have been conjectured on what's this done. We'll talk a little bit about that. And no change in the type 2 because they're not recruiting them. So theoretically, these again are fit soldiers that are basically going out and doing these type of training. And you can see here with strength training, you get increase in both. Combination training, you get no change here, and because you basically did, when you do upper body exercise, what do you do with your lower body? It's a structural support, isometric holds. So it didn't take much to decrease or to eliminate the decrease here for these group here that were training with full upper body programs because they're doing isometric types of structural holding to support themselves for the other exercises, which is an interesting finding and may be related to some of the other studies that have looked at this. Upper body, obviously no change, and no change here. So the key thing here is this is the upper body structural support combination here, no change. So they were able to do the structural hold and everything else, but they didn't see this. Well, this is good because you don't lose connective tissue with that phenomenon. But training-induced atrophy was a possibility at very high intense oxidative stimuli. So if we look at the influence, concurrent training can reduce type 1 muscle fiber size, okay? So this reduction in size might also be related to the, as Per Ergaard reflected again, the maintenance or the improvement of actual aspects of oxygen transport. The distances that you have to go as an oxygen molecule to get to where you're gonna get to in the mitochondrial and respiratory chain is decreased, and the temporal timing is decreased. So if you look at some of the animal studies, you'll find out that every type 1 fiber, when it starts to be stressed by size increases, downregulates all of their anabolic receptors. Testosterone receptors go downregulate, and they don't interact. They want to stay at a certain length. There's a cell size theory that's very important to understanding how cells respond to their environment. So this is part and parcel of that. Now, if you look at the construct, and this has gone on, and there's many people will talk about this. I read about 4 or 5 reviews, and all we know is the fact that if you look at the phenomenon in large muscle groups, and not small muscle groups because they differ, you're going to see that the twitch response to fatigue, when you're fatigued, you're elongating your twitch response. When you're looking at the normal twitch response, even through the type 1 fibers, the peak torque is there. We did a study on marathon runners, pre-post marathon runners. Their peak wasn't changed. What it is, the amount of time it took to get the peak was elevated. So there's a difference in how the recruitment pattern is looking at with regard to the recruitment order and probably a number of other neurological functions that are still being investigated. So if you look at the phenomenon, what happens is that motor units are activated. You're asking them to produce maximal force, but again, in a combination of oxidative metabolism requirements, atrophy, changes in some of the activities of the nervous system, you're not able to get that same adaptive response as when you're doing the modality by itself. Well, how do you deal with it? That's what we'll talk about later. So the classic cartoon we have in our books is up here is where the compatibility problems occur. It's occurring more so in the recruiting fibers that are asked to do both things, and this varies across athletes. Some athletes don't have the same motor unit array. That's why it's difficult experimentally. They're differential. If we deal with an elite endurance runner, they don't have very many type 2 motor units. Versus a person who's 50-50 fiber type, it's a different phenomenon, but it goes back to what's being asked to do the same task over again twice. And obviously, if you look at the higher levels, you're looking up here is where the high eccentric forces and the high damage can occur when you're looking at also the stimulus for protein synthesis and things like that. Now, can you get protein synthesis? The ridiculousness in the literature today. Can you get protein synthesis by doing 30 reps? Yes. But what's the transition coming from? It's coming from those motor units which are going through the process of that, not all motor units. The problem is they're not separating out the phenomenon. And they also are not contributing to the non-contractile protein synthesis versus the contractile protein synthesis, which we've known since Bob Wolf's work is differential. So there's a lot of aspects that happen with regard to how things go and in what people and also mass. The other thing is when you look at anything to do with fibers, if you don't have a single fiber type of phenomenon, sometimes you get a dilution effect on some measures. So if you look at fiber responses to concurrent training, Bell did a little bit of work with more endurance athletes, and basically looking at 72 to 84% of the 1RM, looking at about 90%, around for the VO2, pretty intense type of cycle training again. They basically came back with the fact that they used both men and women. Women haven't been studied extensively except through a few recent studies, actually one recent study, but you're going to see that again, there's potentially the phenomenon where you're going to see the elite athlete kind of have a magnitude problem of how well they're going to get their VO2 max up increased. So endurance training, effects still are not impacted by the addition of resistance training to men and women, but again, the magnitude may be something we have to look at. Strength training adaptations, the same thing. If you're strength training in both of them, you're going to see improvements in both isolated as well as multi-joint. So the effects are not impacted with the addition of endurance training in both men and women. So we see this repetitively over the past many years, okay? And what we really look at is the fact that we're thinking about what the programs are, okay? So again, but what was found again here in this study, the take-home lesson is endurance training again mutes type 1 fiber increases in size. And that's something that either you maintain it, remember, or you can mute the increase, or you can see decrease if it's isolated to a higher enough intensity of endurance. So we're kind of looking at these type of things as repetitive type of phenomenon that we see in the literature and when we put the two different types of programs together. Now, this has been found in similar studies. If we look at the other ideas, and their hypotheses are many, and with all the reviews coming out, speculation on mechanisms and how they relate are going to be proliferative. The hard data sometimes is harder to come by because the study designs don't directly address it, and that's part of the issues that we see. So it could be catabolic events, and we've looked at glucocorticoid receptors as downregulating immune cells. We know that downregulation of immune system to make them inactive is bad for repair because of the fact that you have cells that are very important for cytokine release, for hormone release even from the IGF system, but they're inactive and they don't do anything. All they do is recruit it and they're brought to the area. So there's a lot of different aspects that we have to understand with regard to the systemic roles of recovery and repair that maybe sometimes aren't done. Hormonal have been debated back and forth. What goes on? It's really about the receptors. okay, and I know our work on receptors on immune cells, receptors in muscle, if the receptor doesn't bind to it, the signal isn't translated. Okay, that's the first rule. So our work in the 1980s, 90s with increases, some of it has direct relevance because of translational systemic mirroring of stress or mirroring of different things, but a lot of things have a much more complex interpretation. For example, growth hormone, of which there are 100 different variants that we're talking about. So, but if you see the loss of this whole phenomenon, what you think is the less of hypertrophy, again, is trying to optimize oxidative type of phenomenon, and really you don't see much of a problem with aerobic function. Now, here's one study that shows you when you're implementing with athletes a strength training program, it's probably not a good idea to go wade into it full term. And that's the idea that, again, what's the logic of the program design? Are you going to put in a heavy program right away and then see you're going to get this acute type of phenomenon that we've known from Cellier's theory? You get the alarm reaction. This is a classic alarm study where you see they 3 times a week added resistance training into competitive cyclists, and basically what happens is that, what happens? Well, their whole ability to look at competitive time trials at a kilometer, to do other things, all decreased compared to the group that didn't do it. So you're not going to see the benefits of a strength training program during the acute alarm phase in a competitive athlete. So timing of when you and how you introduce strength training is really a watchword here when you're dealing with competitive endurance athletes. So 6 weeks of resistance training doesn't help you in any type of time trial or augment any type of performance when you're just putting it in the early phase of a training program, because you're seeing the alarm phase that's been so nicely demonstrated over time. So another thing that's become popular, and basically, is how do we do this? When they use women in this case and athletes, this is a circuit program. You know, we keep redefining what were circuit programs from the 1800s, and historically, we need to read our history a little better. Essentially, what this study tried to do with these athletes, soccer and volleyball athletes, is that they looked at training protocols, and what they did is they wanted to know, do I do a serial exercise where I do my resistance first and followed by aerobic, or do I do an integrated light program where I do basically, change it up where I'm doing both aerobic and resistance over the same period of time. And they found out that this program here, using light weights, look at 8 to 12, 50%, and they're looking at, 1 to 30 seconds to a minute aerobic exercise with these 9 resistance exercises. So it's really a kind of circuit program that really demonstrates what did they find. Well, in fact, what the sequence finding is the sequence, the integrated one, is better than the sequential one. So light circuit training with endurance programs, your integrated circuit, boom, 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 that people knew about for years, is probably the best relative to seeing the most changes in cardiovascular as well as physical functioning. So here's the one study that actually gave us some information on the compatibility of different things relative to running and cycling. And we mentioned before that probably running is more dangerous or more demanding than in fact looking at cycling. And they did this type of training, and they compared with cycle ergometer versus incline treadmill running, and they added it in, and they found this. So you can see here the cycle group, you can see basically didn't have the same problem as the running group. So there is a potential modality thing you got to consider, but a lot of athletes, you have to run, so you got to run. But then again, how much supplemental running you do is really important. We found this out when we did gymnastics training. Worst thing you can do with gymnastics or wrestlers we've worked with is send them out for a 5-mile run for either body comp or weight management, because it's hurting power, okay? It's hurting power. So it's less disruptive because of the things we talked about before, and this is one study to give an indication of that. Now, we did a study in older individuals, and more studies are coming out in older individuals to try to see what happens with prolonged training over about 21 weeks in a group from Finland, and we looked at this whole thing, and we tried to look at the same questions, and basically what you're seeing here ultimately is that you're seeing the same thing as you see in the younger aspects. When you do both resistance training and strength training and endurance training together, you're affecting the type 1 muscle fibers. So with strength training alone, you get this dramatic increase in cross-sectional area muscle fibers, both in 1 and 2. When you do the ones here that are just endurance alone or both endurance, you find, again, you don't see the changes in the fibers that you would expect. And again, it's the ability to have oxidative versus anabolic properties coming through. So if we see this is optimal for older people because of sarcopenia. So you got to be careful. And again, we use cycle exercise in this study. You've then got to be careful how you put it together and monitor. Otherwise, you could be doing just the opposite of what you're trying to do in favor of cardiovascular health, but they're going through no help for the sarcopenia that may exist. Nader Group made a great review paper, and he puts this thing in this paper in MSSC in 2006. And it just talks about the energy model from endurance to strength and the type of energetics that are needed. I think we know that. So depending upon the type of exercise you're doing, all the way to here, you're going to see that the stress from oxidative demands for oxygen transport or the stress for high force or power production are quite differential, and you can see that. So again, if we look at signaling effects, this is what we get into. I was going to show you a whole signaling phenomenon, and reality, it's so complex and so interactive. People have been working on this, and you just pull out pieces. So I'm always amazed when people think they really got a handle on this stuff, because it is like dealing with the universe. The bottom line is, one of the things we've found, you're going to find, is that the testosterone action, despite colleagues who have done poor research on this, is really important. And one of the reasons it's important is just basically its cell signaling phenomenon is unbelievable. But the problem is testosterone is a signal hormone. Goes up, signals, goes down. So you got to capture it in very short periods of time. You can't have, nothing's accumulating. We got people correlating, accumulating measures with signaling measures. You can't do that statistically. As my biostat professor would tell me, you got to understand what you're associating and make sure they're relevant. If you look at some of the fundamental work here from Shelley Vassan, one of the things we're working on now, and I think is going to be interesting in the future, is T is very dramatic in how it affects satellite cells. And remember, satellite cells do a number of things. First of all, they provide the pace to put things back together again. And we know right now that you get basically activation, you get differentiation, and you get proliferation. And all those are needed in order to put things together from a damage that occurs from just doing anything in fibers. As well as they contribute to daughter nuclei when you get above, according to Dr. Baumann at UAB, above 25 or 28%, to provide nuclei that actually contribute more daughter nuclei so the domains are maintained. And one of the things we found in our spaceflight work is you do get nuclear apoptosis, and this is really interesting and important to understand as well. So signaling is much more complex than what we're doing right now with regard to how the whole thing kind of works. So if you look at antagonism, there's the dual demands of motor units. Stimulation of catabolic signaling for good and bad purposes. Not good or bad, it's trying to reduce size. AMPK signaling, which is the energy thermostat of the body, which is saying you're doing too much work and will stop making protein that's energetic, stop doing things that are energetic, the volume of work overreaching. Solution is rest. Solution is reduced volume. Solution is basically understanding the compatibility and diagnosing capability of athletes. The solution is periodization. The solution is individualization and careful sequencing of these things through a week. Also, if you look at the problem, too much intensity, exercise as punishment in the coaching realms. Great study done by Dr. Fry. Didn't get a chance to do this at Memphis. They had strength training in the off-season with their football team. Coaches came in, put a bunch of junk in. They were back to where they started after that series of football practices. So you can actually step on your tail, so to speak. So from that standpoint, you have to understand to eliminate some of these practices and understand sport and really training in a much more quantitative manner, and you have to deal with the outside elements such as coaches who are doing weird things. So the situational context is important. Protocols, overshooting, too much too soon, inadequate stimuli, and then lack of recovery, nutritional aspects, which all combine in this universal that we see what we call sport conditioning and strength and conditioning in general. Well, I will try to answer a couple questions. I know Dr. Dudley's legacy lives on. Dr. Fleck was a classmate of his at Ohio State University. I know I was fortunate in '77 when they adopted me as a doctoral student out at Wyoming, and was able to feel a part of a group which we didn't have at Wyoming because I was in a zoology department. But I think his legacy lives on, and I think from the standpoint of what he's done and the kindness he showed, he always showed altruism for other people. He used to tell people working on grants that were going to go up against his, he used to tell them what he knew. And he used to help them out in the lab. He took me in the lab and taught me, along with Dr. Starrin, about all the fiber stuff we did for years. So one of the most caring, kind people, and he definitely will be missed, and he was gone from this planet far too soon. So with that, I want to thank you for your time and attention today, and I hope you got at least one thing you can take away. Thank you very much.